Hello and welcome, and thank you for joining our Spotlight series on PLM. My name is Michał Sieradzki, and I'm going to be your host for this session. Today's session will be presented by Alexander Capone and Matthias Holgersson. We highly recommend that you call into this webinar from your mobile using local numbers provided. For best experience, please also close all your other applications for the duration of this webinar. This webinar will take approximately 45 minutes, including a short Q&A session at the end. Since everyone on this call has been muted, please type your questions into your GoToWebinar control panel, and we will bring them up during the Q&A session. Now, without further ado, I will pass the puck to Matthias.
Good morning and a warm welcome to all of you. My name is Matthias Holgersson, and I'm the head of our Scandinavian PLM Center of Excellence. First of all, I would like to thank you all for joining our webinar today. I'm really happy to see that we have so many participants in today's session. In this webinar series, we will talk about PLM and its role in the age of Industry 4.0. PLM has become an important Industry 4.0 driver. Its importance is paramount, and the explanation is quite simple. PLM is a large reason that digital factory transformation is happening in the first place. And today, we will talk about digital twins and AI to transform the industrial system. We will listen to Alexander Capone, who is the VP Global Digital Manufacturing at Capgemini. He will share some of our experiences around different digital twin technology, how we connect model-based simulation with shop floor connectivity, and how to use digital twin to optimize AI application. But first, I would like to take the opportunity to inform you about our capabilities and the background to the webinars. Are you showing this slide? I can't see the slide.
Yes, I'm showing the slide.
Okay, thanks. So, first of all, I guess you all heard of Capgemini's acquisition of Altran. Two industry leaders joined forces to support customers throughout the entire life cycle of products and services. Together, we will focus on intelligent industry, and together we will form a major global player with more than 270,000 employees in more than 40 countries. And in Scandinavia, we will now have more than 5,000 consultants to support our customers. And when it comes to PLM and digital manufacturing, we have a strong global presence. We have more than 1,500 consultants working within the PLM area all over the globe. As a technology independent partner, we can deal with solutions at different platforms. We have both global and local strategic alliances with the major software vendors like Aras, PTC, Siemens, and Dassault. We have a great global PLM footprint, as you can see in the lower right corner. We have customers in several different industry sectors like aerospace and defense, automotive, industrial equipment, high-tech, energy, consumer packaged goods, retail, and so on. And from the beginning of this year, we also have established a local PLM team, a Scandinavian PLM Center of Excellence. With this growing team, we will have the ability to support our Scandinavian customers, both locally and globally. And this team it's just in its beginning, and we will continue to grow. And at the same time, we will leverage our global capabilities and bring our global knowledge, experience, and assets to our Scandinavian customers.
Sorry, could I just click in? I think we're experiencing some issues with the presentation. Alexander, could you please try to share your screen one more time? Stop sharing and then share one more time, please.
Do you see my screen?
I couldn't see it.
my screen now?
No, we just see you. Yes, now we see it.
Now we can see it. Okay, okay.
Perfect. Sorry for that.
So if you just go 2 slides back, and I will not repeat everything, but it was to just want to show them. Can you do that, Alex? One more?
Yeah, one more.
Yeah. So this is the global customers that I was talking about, and the partnerships that we have, and our global capability. Sorry for that technical issue. Next slide is just a short view of our local PLM team, our Scandinavian PLM Center of Excellence, and still growing as we speak. And next slide. Well, yeah, there. And when it comes to end-to-end digital, this is our vision. Many companies today are using CAD, PDM, and PLM for their engineering department. But to really get the maximum value out of these systems and to reach the goals, we need to think bigger. We need to implement an end-to-end digital thread and use the same data from manufacturing, after sales, and services. We need to connect the physical product with the digital twin and get real-time data back in the engineering process. First then, we will have a chance to really shorten time to market, improve our efficiency, reduce cost, and deliver the right product. And when we talk about the digital twin, it's not only about one digital twin, it's about a digital ecosystem containing of several digital twins connected together, exchanging real-time data from design to use. And my final slide. If we look into the Industry 4.0 landscape, there is a lot to take into consideration regarding PLM. We all know that Industry 4.0 is about automation and data exchange in manufacturing technologies and processes, which includes like cyber physical systems, industrial Internet of Things, cloud computing, AI, and much more. And PLM is the backbone of this landscape. For example, PLM provides the digital models in an up-to-date manner throughout the entire product lifecycle. PLM manages the product data and controls processes such as requirements management, change management, and approvals. And PLM also provides methods and tools for digital manufacturing. And as you all already know, PLM has transformed in the last 25 years from a simple drawing management system to a cornerstone of enterprise IT alongside ERP, CRM, and supply chain management. In the beginning, the focus was mapping complex product data structure and integrating CAD systems for mechanical design. But today, in Industry 4.0, the need for a digital thread, digital twins, and digital continuity have increased the complexity. PLM needs to manage globally distributed development processes. PLM needs to meet the increasing demands from customers, such as systems engineering for mechatronic products, or digital manufacturing for the integrated planning and development of production processes. So to summarize these, PLM has really become an important Industry 4.0 driver, and its importance is really paramount. And this was a short introduction and also some words about our capabilities. And with these words, I would like to hand over to Alexander Capone.
Thank you, Matthias. Hi, everybody. My name is Alexander Capone. I'm part of the global team at Capgemini. I'm the VP of Global Digital Manufacturing inside the global team of Capgemini. Today, we're going to talk about leveraging AI using digital twin to transform the industrial system. And if you have any question at the end of the presentation, I will be glad to answer to those questions. Really quick, we have some assets at Capgemini. We have the assessment assets. We have some PLM lab assets that help customers around PLM. We have also hybrid simulation using our Open Cascade portfolio. We have some boosters. We have the PLM boosters and manufacturing boosters that help us to develop a DevOps approach around PLM implementation and manufacturing implementation. We have our migration framework that we help to migrate when we do new implementation, new PLM transformation for a company. We have also our cloud approach, PLM. That means we can also help customers for our PLM cloud. And we have our PLM hub that help us to scale up team. Using our school, we have a PLM school based on the Dassault system product. From the product life management to digital twin lifecycle management, we mostly do all the industries for the industrial system. On the left side, you will see that we are talking more around digital engineering and manufacturing, where we have a product concept, a product design connected to process design, and after that, resources coming in that we consume inside the process. We have the digital twin concept that we're going to talk today. We have a virtual product connected to our virtual production, and that virtual production is connected to the real production. We have our digital system twin, and after that, we bring to the real product. And what you see at the below here, we have a continuous improvement in development for our tool chain. We can connect the virtual product with real production, give continuous improvement for the real production on the market. And we specialize also on the virtual production and real production. We will see some example later on, where we use continuous development and continuous improvement of the industrial system. Around that, we have a collaborative platform connected for to be able to connect all those systems. And again, with all that, we have our machine learning inside of data to be able to do machine learning around product and around our industrial system. Let's start with the different type of digital twin. I think everybody starts to understand what is a digital twin, but today on the market, you have three types of digital twin. Those digital twin are not new on the market, but I wanted to put it there to at least people understand the concept and how we brought those concepts inside Capgemini. We have a digital twin type 1, that is a digital twin prototype, where we use a conceptual design or a design of, we can call it digital mockup. We have a digital mockup, but that digital mockup is not only digital mockup, because we connect that to data that is probably coming from product that already been built, or with some predictive data that you can create. We have the second step. We have a digital twin instance, where we already have the digital virtual product and the real product, and we start adding data coming in to give more information to the digital data to be able to optimize the data, to optimize the virtual data. And we have the last one is the digital aggregate, where you have multiple instances in the world, and you use that to optimize your operation, to bring that data inside your digital mockup and optimize it for your digital mockup and digital. We decided to put this type of concept because we think that today because digital twin is a trend word, everybody's using it. We want to be sure that our customer is using wisely, and we can qualify some digital twin inside their business. And we decided to put some life cycle phase around that. And if you look at the top here, we know that today we have three type of digital twin, and we decided to put the concept on the top of that. You see, we have the concept, development, and operation, and those three life cycle are connected to our three type of digital twin. And if you look at the bottom, we have a model service, and we have a virtual and physical data. It's really important to understand that. Inside, to be able to qualify the digital twin, we have embedded software and information system. We put some of them at the bottom here. This is some example, but you can add more. We have 1D, 2D, 3D simulation that also it's in the bottom. We put some example there, but we can add more. And we have all the data here that we put the data, the 4D data. Why we call it 4D? Because we have also time acquisition now to be able to understand in time what is the type of data we receive. And you see each instance, each concept here, you will have their own data coming in. And at the end, you have multiple instances coming in. You can have data coming from weather information or other type of information that will probably help to redefine a new concept. And we use an MBSE approach for an end-to-end to help do all the requirements, logical and functional. You know, the RFLQ that we use today, plus the MBSE approach. We help the customer to create an end-to-end approach. Here's some example of a product and industrial system. It's an example on a concept, development, and operation, where we see here a pump that is designed. We have a pump that is connected, and we have a pump used in multiple places. And you can see we have multiple type of digital twin. We have probably here a pump that is used inside an elevator. The elevator probably needs that pump to do some assessment to understand the data. And we have multiple elevators inside the building. That means we can have also multiple buildings inside the city. You will have different type of way of understanding the digital twin. For industrial system, you will have, again, designing your line. The line is not still built. We are designing a line. We have all our industrial system built together. We can use data information like the MES system, ERP system. We can also use all PLCs that are already been used to do our simulation. We create our line. We have now a full digital line connected. And after that, you have multiple operations that you can use to be able to optimize the system performance of your factory or multiple plants you have in the world. Some pain point that some business gave us. We did some workshop, and we mostly see those 5 of them. But you can see we have multiple pain points depending the business. But we see that today, mostly people want to accelerate the time to market, manage the calibration, reduce cost to design, cost to produce, cost to maintain, eliminate downtime for production and production, create better product, manufacturing line, process system. And we decide to put that together, you know, the business objective where we see time to market, enterprise collaboration, cost optimization, performance efficiency, new service and product. We decide to put some example here where you see on the concept development operation, the 3 phases that we decide to put there, we see some of them can be used on mostly on a concept phase, on a development phase, and on operation phase. We use our own implementation assessment framework. What we try to do today is we try to give quick wins to our clients. Sometimes a digital twin of a factory, it's probably a long-term achievement where you can have it can take you 3 to 4 years to implement the digital twin of the factory, or it can be also a product. But what we decide to do is that we have a framework that we help customer to define, qualify digital twin use case, target benefits. That means we put benefits around the target. We capture the use case and we define roadmap with quick wins. We give some example here of time to proceed. This is where you define and how you can execute your KPIs. And after that, we implement those quick wins inside the company, the enterprise, and you can see really quick benefits using digital twin. And the end goal is to, once you did all your quick wins, it's to achieve the full digital twin. Now, if we go back to the terminology of this presentation, is how we can bring AI in our digital twin use. That means if you see today, mostly people are sometimes people are in phase -1, but mostly people are in phase 0 where they already get the data because everything is about the data here. And after that, we have phase 1 where AI and human take decision and human accept the decision. And we have phase 2 where the AI takes some decision. And mostly company today, are here. What we're trying to bring them is around here. And if we go see, we have some company that they are here and they want to go there. If you look at our framework around the digital twin, we have this type of framework. That means we have a snapshot of the framework where we have the strategic input, the model-based production input coming in. We have the product data source where we have product process that resource coming in. We have all the MBSE approach. For us, MBSE is a central point, really important. Even also the information system design assistant where you have a search. We have after that simulation capability for industrial system where you can do line simulation, flow simulation, virtual build, virtual commissioning. And after that, here we have some AI engine that can help, and we have some discovery AI around the digital system and performance production. Here, an example of a company that asked us to do a rate augmentation. The goal here is to be able to do predictive scheduling and line balancing. That means for industrial system, we have something that is really, really complex. And what we're trying to do with a digital twin is to create data that is not existing. That means we create some data that we use a predictive model. We pre-process the data and train. We develop that predictive model, and we go to the end goal to have a predictive scheduling and line balancing for this customer. And again, we use our framework to go with quick wins. If you look at the process step, and again, you know, a digital twin of a process, we use a 3D simulation, and you can see really quick here, we have, and this is really condensed workflow. We have more than that for workflow for rate augmentation, but it's to give you an idea of step-by-step that we take in account. We have a macro flow validation. We have a simulation with associate assembly parts. We do a final scheduling and balancing of the line. We adding resource envelope and simulation, and we do some equipment simulation. And for that, we use our framework that we are building. It's the flow data information. If you look here, we have the model-based platform. If you remember, the model-based platform is for the 3 steps that we have on a virtual build, where we have the information system, embedded system, 1D, 2D, 3D simulation, and we have this type of digital simulation coming in. We have our own Capgemini semantic layer that help connect the virtual environment to all the model-based simulation platform you use today. And that can come from different type of tool you use. You can use Siemens, PTC, or Dassault system tools for be able to bring the right data in those simulations to understand and remove assumptions. And we have an execution layer. And again, really important, it's not coming from direct from production. It's a virtual architecture that we built. And that execution layer helps to bring the right data in, and we execute that data. Again, this is a CapSem execution layer created by Capgemini. It's a Capgemini framework where we import the data inside our model-based simulation, and we do all the simulation. And again, the goal is to be able to go for a scheduling and line balancing. For be able to do that and be able to iterate really quick, we also use our Capgemini manufacturing DevOps framework. It's to be able to plan, code, build, and test really quick inside the system, release and deploy inside the manufacturing operational architecture. And again, once you have a shop floor feedback and optimization, going back in to redo this type of plan, code, build, test, and release. And we use that to be able to go through a digital twin rate augmentation with some AI inside to go from a digital twin to an AI predictive model. And that's helped to benefits on a digital twin platform. And really, again, I'm always cautioned to talk about numbers because you need to talk about the as-is and the to-be. And the as-is of the to-be is the key benefits here. It's a production lead time. The design lead time up to 15%, resource efficiency of the shop floor up to 40% and stock ratio up to 5%. This help, again, we have our framework on the top. Remember, industrial system, embedded software, 1D, 2D, 3D, and 4D for data application. Another type of digital twin we have on the market is using, if you remember, we talked about digital twin concept, and here we use the data set around the ML using synthetic image. And if you look here, we render image using a synthetic image. That means you have parts that are you can use a different type of tool to do a synthetic image around that. And after that, you apply that on your model that is real data. And the goal is to use that to do vision inspection on the shop floor to be able to accelerate vision inspection and take better decision. This is only to be able to help you to increase quality of your product by using vision system. What we use here, it's a deep learning AI vision implementation, and we use those type of rendering. That means once you have your factory or some part of your factory built, and you have some viewpoints of your factory you would like to use it, you can start doing rendering pictures and implement that inside your vision system. And again, the vision system helps you to increase your quality. You can also use, now we go to extreme simulation. You can also use train neural network over digital twin simulation, and I put here OpenAI because they show, and even NVIDIA show the capability of that simulation, where we trail neural network on 10,000 simulation, where we simulate in virtual all those simulation capability. That means we use data coming from a simulation tool. And here you see a robot picking parts, but doing bin picking parts and simulate by himself to understand what's happening. And here we have the ends with different type of color. That means you see the color here is to show the different environment you can have during your simulation. And we use a domain randomization to do that. This is a new type of way of doing 3D simulation around 3D data. Once we add the data, we apply that on the real world. And like you can see here, again, it's coming from OpenAI video. You can see that they did simulation of their block in 3D, and they brought that inside the 3D simulation here, and is doing the RoboCube the first time by using the simulation applied in virtual world. And from that, after that, the robot knows what's happening inside his environment. And what you can see on the second simulation, they went to a level up where they did some problem on this type of simulation. They tied up fingers here to be able to continue the simulation. That means he was able to continue that type of simulation without having new input from his simulation and really coming back in, and he was able to complete. The real goal today, when I'm showing you that, is this is what we can do today with AI using a digital twin of your product or of your industrial system. The real goal is how can we apply that on industrial system? How can we use that type of technology today once we have everything in to be able to apply that on our digital twin factory or digital twin industrial system? And that is where we have the extreme information around our simulation, where we have digital twin network over digital twin simulation. Now we can go to questions. I know that we thank you very much for listening to the presentation. If you have any question, I would be glad to answer some question around the digital twin using AI.
Yes, thank you, Alexandre, for a very nice presentation. Let me see what questions we got here. So I have a first question for you. Do you consider analytics part of digital twin?
Analytics is part of the digital twin. Analytics is not a digital twin. A lot of people, and you see on the market today, you will see that people is trying to understand and try to see that, or trying to sell you that analytics on the shop floor is the digital twin. Doing predictive maintenance on the shop floor, it is a type of analytics using AI. You can use a digital twin to create that predictive model, but analytic is not a digital twin. But it is part of a digital twin because you can use analytic to clean your data, to understand better your data, and you can also use analytics to create or to use that predictive model that you create. But AI, I mean, analytics is not a digital twin.
Thank you. We have some more questions, so I'll get to the next one right away. You spoke about DevOps. How do you implement DevOps for manufacturing? Does it help the organization?
Yes, okay. It is, and we have a framework. That is a good question because we have a framework around the DevOps approach for manufacturing, where we help customers to accelerate their implementation. Mostly, when you design a product and you put that product inside your factory, mostly almost all companies stop their line for at least 2-3 weeks to implement new product, new change on the line, and restart. And when you have more, the takt time is really low. That means really quick. More the ramp up can take a long time. And what we do with our digital framework, we did that with some customer, is that help them to try to get to zero downtime to push that information. That means we have our DevOps approach that we do the same life cycle that I show you during the presentation when we have the plan built, the plan code built and release. And after that, you go through operate. That plan helps you to accelerate implementation. And what we do is we do PI planning inside of that. It's the same thing when we do any software programmation. That means if you do a software for your company, you have a software, you use already the DevOps approach. It's the same thing. That means we do a PI planning around that. We go through the PI planning. We put the one that is necessary. That means that can be optimizing PLC, that can be implementing new parts, that can be implementing new equipment inside the factory. And what we do around that, once we have that inside the system, we try to put value inside of that, work on the right implementation, implement that on the shop floor when it's needed. And we already did all those type of simulation. That means we already did the simulation like I show you. You can do virtual commissioning. You can do simulation to be able, you can do impact analysis to understand if it's going to impact the line. You can do fixture analysis, and you can add kinematics on that to understand. And once you have kinematics, again, if you add kinematics on that, we talk about a digital mock-up. But when you start bringing IoT from your shop floor to your digital twin, it's now you get your real data coming in. That means that can be PLC, that can be data for clamping force, that can be data for other type of clamping you have on your shop floor. And what we do with that, we reprogram or we do some analysis and we bring that on the shop floor. And we do that mostly with company who does virtual commissioning on their shop line. And we also do that on the manufacturing side of it. And something really new also, we are working with a company also on the engineering side of it. We're trying to apply also the DevOps approach, where instead of designing on a waterfall design, we try to design on a DevOps approach where we have a PI planning, we work in Agile, and that agility, we implicate those manufacturing to that agility, and we have a co-design perspective between engineering and manufacturing. That help also to accelerate new product on the market. By adding your digital twin of your factory or your product, it's helped again more to accelerate that type of implementation.
Thank you. Next question. You mentioned complex architectures to support digital twins. Is that investment a prerequisite to developing digital twins?
Yes and no. Mostly today we are talking about smart factory. We are talking about digital twin. We are talking about digital thread. A lot of threads word we use today in the market. It's not the way we work today. I show you during the presentation around our assessment. We try to bring the quick win to our company, to our partners company that ask us to develop this type of implementation. That means to be able to have a full digital twin, it's probably can be a lot of effort. Some people see 2-3 years, doesn't see any benefits because it's a long term, and they say in 3 years I will start receiving my benefits. But if you're starting at really attacking from a standpoint where you do the quick wins implementation by using an assessment, and again, we work in agile way to do that. That means we do an assessment, we do the use case, we put the benefits on that, and at the end for us is each use case, each quick wins we implement are helping companies to accelerate and achieve their KPIs. And once you achieve their KPIs, even if it's 1 or 2%, 3% of their KPIs, it's a lot for a company. And what we're trying to achieve from that is reinvest to do the second quick win. And we go from one quick win to another. And at the end, you can start having a smart factory. You can start having your digital twin. Because mostly everybody says, okay, let's go with a smart factory. Yeah, but a smart factory, what do I need to investigate on a smart factory? Some people doesn't know really what to do with a smart factory. We put IoT. Where do I put my IoT? And this type of assessment help you to implement that. We have a customer that we do today. It's a 3-thread. That means we have a digital mockup, we have shop floor connectivity, and we have all the rate flow simulation. And we have 1D, 2D, 3D with the connectivity. And we have also MES system, ERP system inside of that. And what we're doing today, we have 3 threads. And one part of those, we optimize those 3 threads inside the company. That means we do quick wins. But at the end, we connect those 3, and those 3 become a digital twin. And now they start playing with it to understand their capability. And that's how we do that today at Capgemini. We help companies to achieve really quick wins, bring their KPIs up to bring KPIs, and after that, make this reality for the company.
Thanks. And the next question is, when is the right time to develop a digital twin strategy?
Well, it's now. I mean, everything is there. I mean, you should not wait to create your digital twin today. I think mostly everybody already have a PLM platform in their company. If they don't, mostly everybody also have some connectivity on the shop floor, some data. Some people already have some analytic on the shop floor to understand where they are. I think everything is there to be able to connect. What you need today is understanding, centralize that data. That means we have a platform, we have a virtual architecture that it's working great. That means you have your operational architecture in place that's running the factory. That means you have your MES system, ERP system, you have all the connectivity working on the shop floor. And what we bring is another type of platform that is virtual, like I showed you during the presentation. You have your model-based system simulation, you have your semantic layer, and you have your execution layer for the data. And with that, you can execute right away your data. The most important thing that people have today is that they have all those equipment, but they don't know how to interconnect all that to make it work and to get the gain of a digital twin.
And what we do is with our semantic layer, we help them to and our execution layer, we help them to aggregate the data, understand the data, and bring that inside their simulation. And yeah, that's the type of, I think they should start right away. I don't think they should wait. I think everything is there. Technology is there. The technology is cheaper and cheaper to use. And you need to get some good use case to implement the digital twin.
Thank you. And then I have a final question here, which you may have already answered, but I'll read it up to you. What PLM solutions, products, and technological capabilities are we supporting / focusing on here?
Well, we you know, mostly all of them. Mostly, well, the three big ones, because after that you have, when we talk about PLM, we talk about the 3D, you need to be able to do those three types of simulation. And really, if you look at each component is important. For us, we are capable of doing Dassault system. That means all the Dassault system product. We did a lot of digital twin around the Dassault family. We can also do Siemens. We are working in North America on a digital twin for a company around Siemens product, and we also do PTC. That means we have the three big partners. And for the others, example, for the 1D simulation, when we do flow simulation and everything, we have, you know, MATLAB is one of them. You have you have FlexSim, Simulate. It's all data that you do flow simulation. You know, once you can bring, if you can bring data in, we can help to bring data in to get the data. Some of them is only simulation. Some of them you can give input and adding output. That's the most important thing. But mostly we are partnered with all of them, and we can use all the technology. Today, you know, to be frankly, we did a lot of the digital twin around the Dassault system portfolio, but our framework can support all of them.
Thank you. So before I pass over to Matthias for some final words, I would like to thank everybody for joining us today. I will now post a link to our website with our webinars, where you can sign up for the rest of this PLM series if you wish to do so. Please also check out some other ones that we have over there, and feel free to sign up to any of them. Thank you once again, and Matthias, handing over to you.
Yeah. So yeah, I just want to thank you for attending this webinar. And if you have any questions, please don't hesitate to reach out to me or to Alex. And on Thursday we will have our next session, and then we will have Marie Fleur and Simon from Germany, who will present for us. So I hope to see you then. So thank you for today, and have a good day. So
thank you, everybody.
Bye-bye.
Thank you.
Thank you. Bye.